Welcome to the CodeRage XI Deep Dive session, Powerful GUIs using Scalable Vector Graphics and the RiverSoftAVG SVG Component Library. Since this is my first session, I thought I would tell you about myself. My name is Tom Grubb, and I'm the owner of RiverSoftAVG.com. I have over 25 years of experience in software development, and have been developing Delphi components since Delphi 1 and professionally developing them and selling them since Delphi 2. I also write a blog, Words from a Delphi Codesmith, at blogs.riversoftavg.com. RiverSoftAVG products have 100% Object Pascal source code, and they're for VCL and FMX, and support all FMX platforms, including iOS and Android. The components are for artificial intelligence and graphics. There is one VCL-only object inspector component that has been licensed to Raize Software as Inspex. The artificial intelligence components include a fuzzy logic component for reasoning about imprecise or approximate concepts, genetic algorithms and genetic programming components, and an expert system or if-then rule-based component. Graphically, we have the RiverSoftAVG Charting Component Suite, which is a free for non-commercial use with source charting suite for adding charts and graphs. There's the SVG Component Library, which I'm going to talk about today, and Impact, which is a multimedia instrument package add-on for the SVG Component Library. The agenda today is what are SVGs and what are they good for, and how do you use them with the RSCL. Scalable Vector Graphics is a modularized language for describing two-dimensional vector operations in XML. It describes every operation for drawing the image you see in front of you. It's been an open standard since 1999, and it's widely used on the web and can be used in the desktops. Where can you find them? There's many sources of free and commercial SVGs on the web. OpenClipArt.org has an unlimited commercial license, and SVGs are released into the public domain, and it is an excellent source for finding SVGs. Or you can create them yourself using commercial tools such as Adobe Illustrator and CorelDRAW, or free tools like Inkscape. What are the advantages and disadvantages of SVGs versus bitmaps? Well, first of all, SVGs are scalable. They look sharp and good at small sizes and at very large sizes. You can easily edit the components of the image that you see in SVGs, unlike bitmaps, where it's very difficult to select and then edit a portion of your graphic or image. Because it's an XML language, it's generally slower to load, and bitmaps are much faster to load. Since you're specifying every operation that draws the image, they're generally slower to draw, at least the very first draw. And the bitmaps are much quicker. The SVG has been optimized to make it as compact as possible, with inheriting properties and things like that. And generally they are much more compact than bitmaps for medium and large size graphics. Though it's very small sizes like icons, bitmaps can be smaller. Because each element is available, it's easy to do interactive operations, to select one portion of your SVG and to animate them. Generally, SVGs are good for stylized and mechanical drawings, whereas bitmaps are better for the organic and naturalistic images you will see. Here's an example SVG. On the right is a button, and it's described in that XML on the left. As I mentioned, it's a hierarchical XML document, and the top level element in SVGs, everything is an element. So the square you see is an element, the dragon you see is an element. The top level element is an SVG element, and it describes the height and width of the SVG as well as its viewport or view box, which gives the coordinate system for every element within it. Defs is an optional element for containing containing elements that aren't directly rendered, such as gradients and patterns. Here we see two rec elements, and these display the actual button. One is for the bevel in the background, and one is for the button face. A path element is very good for irregularly shaped elements, or irregularly shaped objects, such as the dragon you see here. The actual path has been clipped to fit in this slide, but that element describes the entire dragon. Next, there's a grouping of 4 circle elements, which describe the 4 bolts, if you will, in the corners of the button. And they've been grouped under a group called bolts, which has a stroke called green. All of the circles inside that group inherit that stroke or pen. If you changed the stroke to equal red, all of the circles would automatically be red. So what is the RiverSoftAVG SVG Component Library? Well, it's native VCL and FMX components for Delphi XE4 through Berlin, and provides the ability to read, edit, display, and write SVGs. It uses a GDI plus canvas, which you're welcome to use yourself, for the VCL side of the component library, which provides transparency, clipping, and other features. It supports most features of the SVG version 1.1 specification for static viewers and editors. However, it is best to verify if your SVGs will work with the RSCL. We provide an evaluation version and demonstration applications on the web, which you can download and test your SVGs. Documentation Insight is used for all help within the library. So you have it available not only in a help file, but it's also available in the editor under the IDE Insight. To get more information, go to riversoftavg.com/svg.htm. The RSCL provides many ways to actually use SVGs in your applications. The simplest way is to use them like normal images. The RSCL hooks into the VCL T-Picture architecture on VCL and the T-Bitmap codec on FMX. So what you can do is, with a VCL application, drop down a T-image. As you see here, it adds SVG as a filter. Select your SVG and show it. Now, why didn't it show up? Well, actually, it uses the height and width of the specified in the SVG, and in this case it's very large, so it's created a 1200 by 400 image. So we stretch it so it fits, hit run, and there it is. Now you can also do it at runtime. First, let's clear out the picture we have at design time, and we'll set up on form create. We'll do image.picture.load from file. Now, in order to load an SVG into the T-Picture architecture, we need to include a unit in the uses. here, the rsimaging.svg image unit. So we run, and voila, there it is. Now you can also use SVGs within the image list architecture, so that any button that can use an image list can use them. So we select an SVG image list, we edit it, and then we add SVGs to this image list. Here we add a population and a tree. Now we can drop down buttons that use image lists. We'll put down a toolbar, and let's resize it so that the buttons are going to be 64 by 64. And we'll add 2 buttons. And we'll set the images of the toolbar to our image list. But they're very small. Well, the size of the SVGs are determined by the height and width property of the SVG image list. If we change them, it automatically will regenerate the bitmaps that are used by these buttons. The SVG image list stores the SVG within the image list so that they can always be regenerated at design time or runtime with full crispness. Now you can also do the same thing with an FMX. You drop down an image, T-image, you bring up its multi-res bitmap, you open the dialog, and again SVGs have been added as a filter. So you can select an SVG and it will generate the bitmap for you. So let's run, and there it is. Again, you can do it at runtime. First, let's clear out what we have in our multi-res bitmap. And on form create, we're going to say image.bitmap.load from file. Just as with VCL, the FMX architecture requires a unit be included so that it loads. In this case, fmx.rs.svg codec. So now let's run and see if it works. There it is. We also have an SVG image list in the FMX, though it is more complicated than the VCL version, as there's so much more capability in the FMX image lists architecture. First, you click Add, and you add your SVGs, and you name them. Now notice what we have here is that for each screen scale, you can specify the size that the bitmaps that will be generated from the SVGs. This allows one SVG to handle multiple screen scales. So now we can add the actual items to the image list, and we define the left and right and width and height of each layer. Now we can drop down a glyph which can use image lists. Set the image list and set its index. Now notice it's kind of blurry. That's because we specified a small size for the scale for this image. So let's push it up to 256 by 256. However, we also need to change the layer so it also takes the proper area of the bitmap to generate the layer. And it's very crisp now. So what we're going to do for the rest of the session is we're going to build a application for European motor cars, and this will allow us to do different features of the RSCL and using the SVGs. So we're putting our image up on the left, and we're creating a layout on the bottom to put these other ones for eventual buttons. I want to talk briefly about the RSCL SVG document model. This document model, these classes, closely parallel the SVG document model. There's the SVG element, which is the base class for all SVG elements in the library. There's SVG graphic element, which is the base class for all graphical elements, for things you will see in your SVGs. And SVG document, which is the envelope, the document for the entire SVG, and it can contain all other elements, including other SVG documents. Now these classes are all runtime classes. There's two classes, the TRS SVG document and the TRS FMX SVG document, which provide design time access to the SVG. They have an SVG property, and so you can load in an SVG by clicking on the file name, and if you use the file name at runtime, it will actually load from file the SVG. You can also use the embed SVG as binary and turn that to true after loading an SVG, and that will embed the SVG into the form file as these SVG element classes. Finally, there is a lines property, which is a tstrings property, where you could specify the SVG as the XML string. So now we're going to drop an SVG document down on our form, specifically the TRS FMX SVG document. And we're going to load into the file name property a European Union map SVG that we downloaded from openclipart.org. The application is going to allow you to click on a country, and we would eventually add in information about the countries. Now we drop a TRS SVG image, which we can hook up to the SVG document to show it. And let's align it to client. If you notice, the map is kind of dim, and that's in the SVG, so we need to investigate that. The RSCL provides source code to a simple SVG editor. So we'll start this editor, load the map, and click on a map to figure out what's going on. What we see here is that the fill opacity is less than 1, and that's true for all the countries, so that's the problem. Also notice that the countries are path elements, and above them is a group element that actually labels the country. We need to remember that so we can get that ID for later. So what we're going to do is we want to modify the SVG after we load it. We could try different events, such as parsed the node or whatever, but in this case, onloaded is the proper event. So let's double click and create our event. First, we're going to go through all of the elements in the document. So let's create a variable element of SVG element. We need to make sure we have that unit that creates that, so let's add it. It's fmx.rs.svg. And let's go back to the onloaded event and do for element in the SVG document .svg .all items .values. This will give all of the elements in the document as SVGs. So now we need to check if this element is a graphical element, SVG graphical element, and its brush.opacity is less than 1, we need to change it. Now we could change the brush.opacity to equal to 1, but as I mentioned earlier, the SVGs allow you to inherit a lot. So by default, brush opacity is 1. So we're just going to set the element.inherits.fill opacity equals true. So let's try this. Let's run it and see how it looks. Much better, much crisper, much more vivid. In our app, what we want to do is when a user clicks on a country, we want to show a large blown up version of that country. So let's drop another TRS SVG image onto our form and resize it and make it and center it. And we're going to set the SVG document property to the same document that we're using for the full map. But in this case, we'll set the SVG root ID to a country, and we'll set it to one of those groups, those LA dash groups. Now it's hard to see, so what we're going to do is we're going to drop a shadow effect behind the country so it pops from the larger map. Now we need to go back to the original image and set its onclick element. This is an event that occurs when an element is clicked. In this case, we're going to set up a property which will be set up to be any of the graphical elements that are the current selected graphical elements. So we're going to set it the selected equal element. And now we create the property. So what do we want to do? Well, if value is not equal to selected, it changes. If selected is nil, we want to set that blown up SVG image, its SVG document, to nil, which will make it display nothing. And if it's not nil, we want to set the SVG document to the same European map SVG document and set its SVG root ID to selected.id. Because of time constraints, not shown in this video, is that I've added a contrast effect to the larger European map. The idea being when you select a country, we show the larger country with a shadow beneath it, and we dim the larger map to make the country pop. So because of that, we need to turn the contrast effect, it's enabled on and off based upon whether selected is nil or not. And we also, because of the way FMX works, we need to update the effects of the SVG image 1 and SVG image 2. So we run it, and it works beautifully. Next, we want to make a focus rectangle around the country in the larger map when it's selected. So what we make is a onPaint event handler, and if selected is not equal nil, we're going to draw the bounds rect of the country on the canvas. This occurs after the SVG has been drawn. Now, this turns out to get this bounds rect is a little bit complicated because of the different math and things you have to take into account. First, what you need to do is get the rectangle of the control. Next, the TRS SVG image has a wrap mode property. This controls how the SVG is drawn within the control, whether it's fitted, whether it's centered, tiled, etc. So we need to take this into account. There's a get wrap mode rec method that allows you to get the selection rectangle of the entire SVG based upon its wrap mode. So we have to do the sender as TRS SVG image.svg document.svg because that's what we drew. The rectangle we were drawing into, the wrap mode, and finally the scale factor. Next, we have to use that rectangle to figure out the transformation matrix that was used to draw the entire SVG. This transformation matrix is different based on whether you're drawing the entire SVG or if you were setting the SVG root ID and drawing only a portion of it. I'm going to write this event handler so it can handle both, even though we know it's always going to be the entire SVG. So if the SVG image.svg root ID equals a blank string, we know it's the entire image. First, we need to fit the SVG document into the rectangle, which gives us a transformation matrix, and then call the SVG documents method getViewMatrix, which will take that matrix and the rectangle to give us our final transformation matrix. If we're not drawing the entire document, it's a lot simpler. We just have to get the SVG root, whatever is the root element, and fit it to the rec of the selection rectangle. We're almost there. Now that we have the transformation matrix that was used to draw the entire SVG, what we need to figure out is the transformation matrix that was to draw the actual selected element. This is a multiplication of the input matrix plus the transformation matrices of all parent elements. So what we can do is we can call selected.getTransformationMatrix and pass in this matrix, and it will return the actual matrix to draw this selected element. At that point, all we have to do is get the bounds rect. We call the selected.getBoundsRec and pass in our matrix. And we're finished. We have the bounds rec. At this point, we can set the canvas.stroke.color to gray, and call canvas.drawRec with our selection rectangle, no radius 0, 0, all the corners, and with a half opacity of 0.5. At this point, we're finished. We can run and test it. We can click on a country, we see it, and you can see the focus rectangle in the back. If you notice, there's a slight problem that we don't actually refresh the SVG image between drawing different focus recs. So let's go into the setSelected method and call the RSSVG image1.repaint. And let's run it again. This is starting to look really good and a nice foundation for an application. Next, I'm going to show you how we can use the SVGs to make a button. So I downloaded some buttons from the openclipart.org. So let's drop down another SVG document, set its file name to the buttons SVG, and let's drop down a RS SVG image, and we're going to put it down at the bottom as a button. So we'll set its SVG document to the SVG document component we just set. Now you notice this is actually an SVG that contains lots of buttons. So here we definitely have to set the SVG root ID, and because I examined the SVG beforehand, I figured out which ID is the red button. First, we'll set up the action for when the button is clicked. We'll set it on an onclick element, and we'll say the selected is nil. Our action is going to actually deselect the countries. But we need to actually check that the element is nil first. Next, we want to make the SVG image act like a real button. If you just clicked it now in the application, there would be no visual indication you're pressing down on the button. So what we'll do is we'll drop a contrast effect onto the image. And we're going to lower the contrast. We're going to dim it, actually. And we'll set it to disable it. And what we'll do is on mouse down, we'll turn on the contrast effect, and on mouse up, we'll turn it off. Now we want to make sure the mouse down actually is when an element is clicked in the SVG and not the area around the button. So this is a good case where we need the element at pause or element at position method. The element at pause method accepts a transformation matrix, the canvas we're drawing on, the point we're inspecting, and the rectangle we're looking at. Now, I could go through everything we did with the drawing the focus rec, but I'm just going to assume, I know we're using the SVG root ID, so we can get the fit to rec to get the transformation matrix, put in the canvas, make a point out of the X and Y, and pass in the rectangle we're drawing to, which in FMX is the clip rec for the control, or client rec on VCL. If element at pause is not nil, it returns not nil, it returns the element that was selected. We know we clicked something. So let's set the contrast effect, enable it. Set it to true. And then on the mouse up, we'll set the contrast effect to false. Now we can run and test our button. Can select a country, click the button, and it nicely indicates that you're selecting it. And also stops painting the focus rec. So I have been showing you how to use the TRS SVG image, which works in FMX and VCL, and how to use that with SVGs. The RSCL also has a very interesting component called the TRS SVG panel. And the way this works is that it actually builds controls, FMX controls, rectangles, paths, etc., to draw the SVG. It doesn't work with all SVGs, but it works very well, especially in FMX. The VCL version is not recommended. So we drop down an SVG document, we set its file name, and we attach the panel to the document. Now what we do is we right-click it and say create controls, and it goes through and creates all the controls for this SVG. And at this point we could delete the SVG document. Now that we have the controls, we can select them, inspect their properties, edit them, change them, and do whatever we want. So here we see the feather on the helmet. So let's select the background circle, and let's check the path to make sure it's the background circle, and we can change its fill property. So let's change it to make it a gradient. Now the TRS SVG panel is very powerful, but there are limitations. One being it doesn't work with as many SVGs as the regular controls, but also it is a heavyweight control. Creating all of these controls is an expensive operation. You wouldn't want to use it in all situations, but in certain situations it could be very, very powerful. The final way to display SVGs with the RSCL is to draw them directly to a canvas. Any SVG graphic element has a draw method where you can draw to a canvas, whether on screen or off screen. So what we're going to do here is drop a paint box and use its canvas and set it up to the right as a button where we'll draw one switch on SVG, and then when it's clicked, draw a switch off SVG. Now I should mention this isn't the most efficient way to do it, because every time you're doing a paint, you draw the entire SVG. An advantage of the TRS SVG image is that it actually buffers your drawing. It draws the SVG to an off-screen bitmap and then actually draws that bitmap every time it needs to paint. Unless you actually resize the TRS SVG image larger, it never needs to regenerate that and regenerate the bitmap. So now we're dropping down two TSVG documents and setting their file names to switch on and switch off. And we're going to set up the tPaint on paint event to, depending upon the tag, whether it's 0 or 1, we're going to either draw the switch off .svg .draw, and you can draw it with transformation, but we'll draw it directly to a canvas. And for the entire clip map of the paint box, else we'll draw the switch on SVG. Now we also need to set up the click so it switches between them. So we'll set up an on-click event. In the on-click event, we're going to change the tag. So sender as tpaintbox.tag equals sender as tpaintbox.tag plus 1, and mod it 2, so it switches between 0 and 1. Now every time we change this, we also need to repaint the paint box. At this point, we can just run. You can click on the switch and it switches back and forth. I mentioned earlier that there's limitations to the RSCL SVG support. The main limitations are there are no clipping paths in FMX because irregular regions aren't supported by the Delphi FMXT canvas. There's no masking, there's no filter effects yet, though in FMX you can use their effects. For interactivity and animation or scripting, you can't use the built-in SVG support. You need to use Delphi itself. I wanted to briefly mention the Impact, which is the Multimedia Instruments Package add-on for the RSCL. Impact is a component add-on that adds different instruments and gauges like batteries, clocks, altimeter, barometer, thermometer, over 15 different gauges and clocks. They're all high quality and resolution independent. There's no external files to deploy, and they're easy to use through properties and events. To use Impact, you drop the gauge you want onto your form. Here we'll drop a thermometer, and then we'll drop an altimeter. Impact provides a rich set of properties and events to configure your gauges. One of the most important is the parts property. By toggling different parts on and off, you can drastically change the look of your gauges. What parts can be toggled on and off varies depending upon the gauge, but you usually have a frame, you have glass, you have labels, and many other parts. Another important property is the design property. This toggles between detailed and simple. The simple version of the gauge is without gradients and some parts, and it's generally optimized to draw faster. There are many other properties to change specific aspects of the gauge and parts. For example, you can change the colors of the back face, the frames, the knobs, and needles. You can change labels and captions. Most gauges come with a decoration property. Impact comes with a wide selection of predefined decorations, but you also can override that and provide any path as a decoration. There are over 15 different gauges to spice up your GUIs. From clocks and digital clocks to calendars to 2 different compasses and more. There is a value property for most gauges that you can use to change the level of your battery or of your speed, or an angle property for the compasses. You can change any property at design time or runtime, and Impact will automatically adjust the look and feel of the gauge. Impact has been designed to be very efficient in drawing its gauges. It buffers the background and foreground elements in bitmap buffers, and only changes the dynamic elements when you change the value or angle properties. Here we've dropped down a track bar, and as the track bar changes, we're going to update the value of the battery level. Now let's run and see how the gauges look in action. We select the track bar, and as we drag it, it smoothly changes the level of the battery. I want to thank you for attending my session today, and I hope you found it packed with useful information. SVGs can really make a difference in your GUIs. I want to encourage you to download the evaluation version of the RiverSoftAVG SVG Component Library and Impact and try them for yourselves. For more information, please go to the links on this page. Now for questions.
Like you pointed out, this is your first CodeRage, so welcome to presenting at CodeRage. Congratulations, you've done it now.
Yeah, thank you. I'm not a novice anymore.
So Roland's asking a question here. How well are your components documented, especially interference engine, component suite, fuzzy logic, genetic algorithms, and programming?
They're all completely documented. Um, it- the uh, the inference engine component suite still uses the old style help, so it doesn't use documentation insight, but um, every other component actually uses documentation insight, and they come with, you know, examples, references, everything else, and it's all in the uh, units themselves. Plus, of course, there's a generated help file. Oh, and I should mention that the documentation insight components are also on the web. Um, you will have to go to RiverSoftAVG.com and look for that, but there's the full documentation for all of them except for the inference engine.
Very cool. I was actually talking to Eli earlier, who's running the other room too, and he was talking about how great your components are. So
Thank you.
Yeah. He's like, oh man, he's got all these great components out there. Okay, the SVG component feature list says that the filters and masks are not yet supported. Are there plans to include these features?
Yes, there are plans to include the filters for sure in the next version, and possibly the masks in that version.
Can you generate an SVG at runtime?
Yes, yes. In fact, not really shown there is that you can call a save to file or save to stream for any, at that TSVG document. And as you've changed things, for example, we changed the contrast or the vividness of the map. We could just resave that map out, and it would generate a XML SVG file.
Can you generate an SVG from scratch at runtime?
Yes, you can. In fact, that editor, that simple editor that comes with the RSCL, allows you to drop down components, and it's basically building the document model at runtime that you then save.
Okay. Impact looks really great. What about adding a realistic looking knob you could turn?
That's definitely on our list of instruments to add.
Okay.
I should state you can also sort of do it yourself right now, just using the RSCL like we did with the switch. There's some knobs on the like openclipart.org, and you would just have to hook up to the mouse events, and you could rotate them. But it's not as easy to use, obviously, as Impact with the components, the properties, I mean.
Sure. It's actually really cool looking at watching this one and then thinking about some of the stuff we saw at other ones. I love the robustness and variety in the community, all the different components that do slightly different things or similar things. And it's like, oh, that one does what I wanted to do that the other one didn't, or vice versa. So that's very cool.
Mm-hmm. Yeah, I tend to write the components so that they are generalizable, and then you can do specific things. So like I said, you can draw to the canvas, and that could be a printer canvas, for example, or an off-screen canvas. And then once you can do that, you can do other things and build the components from that. So yes, it's very customizable.
Now, do these components work with Delphi as well as C++ Builder?
Officially, it's Delphi. They do work with C++ Builder, and I have customers who've successfully used it and sent me emails talking about it. I don't have as much experience with C++, and so I didn't want to officially state that we support it, but it is supported. The evaluation version can also build the VCL and Windows FMX C++ version, so you can test it out in that. One of the things about the evaluation version I should mention is that it's fully featured. It just gives you a nag screen. The one feature that's not supported is generating the controls from the SVG panel. But otherwise, there's no limitations.
All right, very cool. Oh, and another question. How well does SVG work through RDP or remote APP?
I don't understand the question. Sorry.
Yeah, I was going to say, I'm not sure I understand the question, so hopefully you do. I think, isn't RDP remote desktop? But I'm not sure what would make SVG work differently through remote desktop. Or maybe it's talking, isn't there like a streaming media protocol or something like that also maybe that is reference to? I'm not sure. So yeah, I'm not clear what that is. Like he's saying is remote desktop. So I guess through the remote desktop compression maybe?
I wouldn't imagine it works different, but I can't say with certainty.
It says bitmaps are slow for remote desktop. So yeah, I would think the remote desktop was just doing a screen grab. It probably wouldn't care what it is, if there's a SVG or a JPEG or a bitmap at that point.
Right.
Because it's not hooking into at a different level.
Yeah, we don't hook into RDP anywhere. So it would be what you see on your screen is what's transmitted.
Yeah. Actually, I really like SVG, and I wish it was getting more adoption because it does have a number of advantages, I think. And there are situations when SVG is far superior to other image formats, but it's not being used everywhere yet. So I'm glad to see your library here and your session on that.
Okay. Well, thank you very much. And I'm open to any questions. Send me an email.
Yep, there's your email address.
Try it out.
tgrubb@riversoftavg.com. Fantastic. GRUBB in Grubb, just in case.
Yeah, I noticed you misspelled that in the opening screen.
Sorry. I will mention this. My two boys have been helping out with CodeRage stuff as interns, so I will blame that on them. Although it may have been my fault, but they're doing doing a good work on most everything. But yeah, sorry about that. Oh, Ken's asking, is SVG sped up via the GPU?
No, I do not use the GPU. We just use the standard. On VCL, we're using a GDI Plus, so that's a software library. And then I'm using the FMX T-Canvas. So it's using direct draw on Windows or OpenGL on the other platforms. But otherwise, it's not using the GPU.
Well, if you're using the T-Canvas, then I think there is some. It does offload automatically. FMX does automatically, since it's using OpenGL, offload onto the GPU for the rendering.
Yeah, for that part of it. But like I'm thinking of the filters that we're trying to add now. We're probably not going to use the hardware filters on the card.
That makes sense. Very cool. Actually, when SVG first came out, I was playing with it just because it sounded like a cool technology. That in VRML, which never really caught on.
Mm-hmm. Yeah, and I thought first, it seemed like you all were going after SVGs at first with the using paths for everything in the early FMX. And I guess you got away from it a little bit and went with the pixel perfect bitmaps.
Yeah.
So this is filling in an area.
Yep. And actually, I was talking to product management, and that they were really keen on the SVG, but they found that two things. One was that it was a lot harder to get design or styles made in SVG in vectors, and then also with mobile platforms, it was really important to get that perfect look, because it needed to look perfect on the mobile platforms. And that you couldn't do that through SVG, the vectors, but you could do that through bitmaps. So that's why they went with bitmaps, and that's kind of been more of the focus. So yeah, like I said, I'm a big fan of SVG, so I was excited to see that you had this component and you were covering here for CodeRage.
Yeah, it's complementary to the FMX.
Yep.
Thank you very much.
Thank you.